Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Machine Learning Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You are an ML engineer at a bank that has a mobile application. Management has asked you to build an ML-based biometric authentication for the app that verifies a customer's identity based on their fingerprint. Fingerprints are considered highly sensitive personal information and cannot be downloaded and stored into the bank databases. Which learning strategy should you recommend to train and deploy this ML mode? The options are: Option A, Data Loss Prevention API. Option B, Federated Learning. Option C, MD5 to encrypt data. Option D, Differential Privacy.
To arrive at the correct answer, we focus on the keywords: mobile application, cannot be downloaded and stored into the bank databases, learning strategy.
The correct answer is option B, Federated Learning.
Why is this correct? B. Federated learning enables model training across decentralized edge devices, such as mobile applications, without exchanging local data samples. This ensures the sensitive fingerprint data remains on the user's device, satisfying the requirement to not download or store it centrally. Why are the others incorrect? A. Data Loss Prevention API is a service used to discover, classify, and de-identify sensitive data. It is a data protection tool, not a machine learning strategy for training models. C. MD5 is a widely used cryptographic hash function, not an encryption method, nor is it a machine learning strategy for model training or deployment. D. Differential privacy is a mathematical framework for ensuring privacy in datasets by adding noise, but it is not a distributed learning strategy to prevent data centralization.
You are an ML engineer on an agricultural research team working on a crop disease detection tool to detect leaf rust spots in images of crops to determine the presence of a disease. These spots, which can vary in shape and size, are correlated to the severity of the disease. You want to develop a solution that predicts the presence and severity of the disease with high accuracy. What should you do? The options are: Option A, create an object detection model that can localize the rust spots. Option B, develop an image segmentation ML model to locate the boundaries of the rust spots. Option C, develop a template matching algorithm using traditional computer vision libraries. Option D, develop an image classification ML model to predict the presence of the disease.
To arrive at the correct answer, we focus on the keywords: detect leaf rust spots, vary in shape and size, correlated to the severity, predicts the presence and severity.
The correct answer is option B, develop an image segmentation ML model to locate the boundaries of the rust spots.
Why is this correct? B. Image segmentation provides pixel-level classification to capture exact spot boundaries in area. This is required to accurately determine disease severity since the spots vary in shape and size. Why are the others incorrect? A. Object detection outputs bounding boxes, which overestimate the area of irregularly shaped spots, leading to inaccurate severity calculations. C. Template matching requires predefined, fixed patterns. It is ineffective for detecting biological features like rust spots that naturally vary in shape and size. D. Image classification determines if the disease is present globally but cannot locate individual spots or measure their extent to assess severity.
Refer to the attached Picture 1, reference exhibit. You are training an object detection model using a Cloud TPU v2. Training time is taking longer than expected. Based on this simplified trace obtained with a Cloud TPU profile, what action should you take to decrease training time in a cost-efficient way? The options are: Option A, move from Cloud TPU v2 to Cloud TPU v3 and increase batch size. Option B, Move from Cloud TPU v2 to 8 NVIDIA V100 GPUs and increase batch size. Option C. Rewrite your input function to resize and reshape the input images. Option D. Rewrite your input function using parallel reads, parallel processing, and prefetch.
To arrive at the correct answer, we focus on the keywords: training and object detection model, Cloud TPU v2, simplified trace, Cloud TPU profile, decreased training time, cost-efficient way.
The correct answer is option D. Rewrite your input function using parallel reads, parallel processing, and prefetch.
Why is this correct? D. The trace shows sequential execution where the TPU waits for the CPU and network to prepare data. Using parallel reads, parallel processing, and prefetch allows overlapping data extraction, transformation, and training, resolving the input pipeline bottleneck cost-efficiently without requiring hardware upgrades. Why are the others incorrect? A. Upgrading hardware increases costs and does not address the root cause shown in the trace, which is an unoptimized, sequential input pipeline leaving the TPU idle. B. Moving to GPUs is a costly hardware change that fails to fix the underlying data loading bottleneck. The sequential pipeline will still cause idle time on GPUs. C. Simply resizing and reshaping images without implementing parallelization and prefetching does not resolve the lack of overlap between data preparation and training operations.
You manage a team of data scientists who use a cloud-based backend system to submit training jobs. This system has become very difficult to administer, and you want to use a managed service instead. The data scientists you work with use many different frameworks, including Keras, PyTorch, Theano, scikit-learn, and custom libraries. What should you do? The options are: Option A. Use the Vertex AI training to submit training jobs using any framework. Option B. Configure Kubeflow to run on Google Kubernetes Engine and submit training jobs through TF-Job. Option C. Create a library of VM images on Compute Engine and publish these images on a centralized repository. Option D. Set up Slurm Workload Manager to receive jobs that can be scheduled to run on your cloud infrastructure.
To arrive at the correct answer, we focus on the keywords: difficult to administer, managed service, many different frameworks, custom libraries.
The correct answer is option A. Use the Vertex AI training to submit training jobs using any framework.
Why is this correct? A. Vertex AI training is a fully managed service that eliminates infrastructure administration overhead. It supports custom containers, allowing data scientists to use any machine learning framework or custom library. Why are the others incorrect? B. Kubeflow on GKE is not a fully managed service and requires cluster administration. Additionally, TF-Job is specific to TensorFlow and does not seamlessly support other frameworks. C. Managing a library of VM images on Compute Engine is an infrastructure as a service approach. It is not a managed service and would increase rather than reduce administration efforts. D. Setting up and maintaining a Slurm workload manager requires significant manual configuration and ongoing administration, violating the requirement to use a managed service.
You are an ML engineer responsible for designing and implementing training pipelines for ML models. You need to create an end-to-end training pipeline for a TensorFlow model. The TensorFlow model will be trained on several terabytes of structured data. You need the pipeline to include data quality checks before training and model quality checks after training but prior to deployment. You want to minimize development time and the need for infrastructure maintenance. How should you build and orchestrate your training pipeline? The options are: Option A. Create the pipeline using Kubeflow Pipeline's domain-specific language, DSL, and predefined Google Cloud components. Orchestrate the pipeline using Vertex AI pipelines. Option B. Create the pipeline using TensorFlow Extended, TFX, and Standard TFX components. Orchestrate the pipeline using Vertex AI pipelines. Option C. Create the pipeline using Kubeflow Pipeline's domain-specific language, DSL, and predefined Google Cloud components. Orchestrate the pipeline using Kubeflow pipelines deployed on Google Kubernetes Engine. Option D. Create the pipeline using TensorFlow Extended, TFX, and Standard TFX components. Orchestrate the pipeline using Kubeflow pipelines deployed on Google Kubernetes Engine.
To arrive at the correct answer, we focus on the keywords: TensorFlow model, data quality checks, model quality checks, minimize development time, infrastructure maintenance.
The correct answer is option B. Create the pipeline using TensorFlow Extended, TFX, and Standard TFX components. Orchestrate the pipeline using Vertex AI pipelines.
Why is this correct? B. TFX provides standard components for TensorFlow models, including data and model quality checks, minimizing development time. Vertex AI pipelines is fully managed, minimizing infrastructure maintenance. Why are the others incorrect? A. Kubeflow Pipelines DSL lacks comprehensive built-in components for TensorFlow data and model quality checks compared to TFX, increasing development time. C. Kubeflow Pipelines DSL lacks built-in TensorFlow components, increasing development time. Deploying on GKE requires managing clusters, failing to minimize infrastructure maintenance. D. Deploying Kubeflow pipelines on Google Kubernetes Engine requires managing the Kubernetes cluster yourself, which increases overhead and fails to minimize infrastructure maintenance.
You are developing an ML model to predict house prices. While preparing the data, you discover that an important predictor variable, distance from the closest school, is often missing and does not have high variance. Every instance, row, in your data is important. How should you handle the missing data? The options are: Option A, delete the rows that have missing values. Option B, apply feature crossing with another column that does not have missing values. Option C, predict the missing values using linear regression. Option D, replace the missing values with zeros.
To arrive at the correct answer, we focus on the keywords: often missing, does not have high variance, every instance, row, in your data is important.
The correct answer is option C. Predict the missing values using linear regression.
Why is this correct? C. Predicting missing values with linear regression is appropriate because every row is important, precluding deletion. Since variance is low, imputing values using other variables provides a reasonable estimate. Why are the others incorrect? A. Deleting rows is incorrect because the scenario explicitly states that every instance, row, in your data is important. B. Feature crossing is used to model nonlinear relationships between features, not to handle or impute missing data. D. Replacing with zeros is incorrect because a distance of 0 means the house is exactly at the school, which introduces severe bias.
Your data science team needs to rapidly experiment with various features, model architectures, and hyperparameters. They need to track the accuracy metrics for various experiments and use an API to query the metrics over time. What should they use to track and report their experiments while minimizing manual effort? The options are: Option A, use Vertex AI pipelines to execute the experiments. Query the results stored in metadata store using the Vertex AI API. Option B, use Vertex AI training to execute the experiments. Write the accuracy metrics to BigQuery, and query the results using the BigQuery API. Option C, use Vertex AI training to execute the experiments. Write the accuracy metrics to cloud monitoring, and query the results using the monitoring API. Option D, use Vertex AI Workbench user-managed notebooks to execute the experiments. Collect the results in a shared Google Sheets file, and query the results using the Google Sheets API.
To arrive at the correct answer, we focus on the keywords: rapidly experiment, track the accuracy metrics, API to query the metrics, minimizing manual effort.
Correct answer is option A. Use Vertex AI pipelines to execute the experiments. Query the results stored in metadata store using the Vertex AI API.
Why is this correct? A. Vertex AI pipelines natively tracks artifacts and metrics in Vertex ML metadata store. This automates experiment tracking and provides a built-in API to query results over time, minimizing manual effort. Why are the others incorrect? B. Writing custom code to log metrics to BigQuery increases manual effort and lacks native ML tracking integration. C. Cloud monitoring is intended for infrastructure and application health monitoring, not for tracking ML experiment parameters and accuracy. D. Using Google Sheets is a highly manual, non-scalable approach that lacks proper ML metadata tracking features and integrations.
You recently deployed an ML model. 3 months after deployment, you notice that your model is underperforming on certain subgroups, thus potentially leading to biased results. You suspect that the inequitable performance is due to class imbalances in the training data, but you cannot collect more data. What should you do? Choose 2. The options are: Option A, remove training examples of high-performing subgroups and retrain the model. Option B, add an additional objective to penalize the model more for errors made on the minority class and retrain the model. Option C, remove the features that have the highest correlations with the majority class. Option D, upsample or reweight your existing training data and retrain the model. Option E, redeploy the model and provide a label explaining the model's behavior to users.
To arrive at the correct answer, we focus on the keywords: underperforming on certain subgroups, class imbalances in the training data, cannot collect more data.
The correct answers are Option B, add an additional objective to penalize the model more for errors made on the minority class, and retrain the model, and Option D, upsample or reweight your existing training data, and retrain the model.
Why is this correct? B. Penalizing errors on the minority class, cost-sensitive learning, forces the model to pay more attention to underrepresented subgroups during training, mitigating the effects of class imbalance without requiring new data. D. Upsampling the minority class or reweighting the existing data effectively balances the training distribution, helping the model learn better representations for the underperforming subgroups without collecting new data. Why are the others incorrect? A. Indiscriminately removing training examples from high-performing subgroups discards valuable information, which can degrade overall model performance and generalization rather than effectively addressing the imbalance. C. Removing highly correlated features destroys predictive power, as these features may be essential for accurate predictions across all classes, not just the majority class. Why are the others incorrect? E. Providing a warning label does not solve the underlying technical problem of model bias and inequitable performance caused by class imbalance.
You have developed an ML model to detect the sentiment of users' posts on your company's social media page to identify outages or bugs. You are using Dataflow to provide real-time predictions on data ingested from pub/sub. You plan to have multiple training iterations for your model and keep the latest 2 versions live after every run. You want to split the traffic between the versions in an 80-20 ratio, with the newest model getting the majority of the traffic. You want to keep the pipeline as simple as possible, with minimal management required. What should you do? The options are: Option A, deploy the models to a Vertex AI endpoint using the traffic split = 0 = 80, previous _model _ID = 20 configuration. Option B, wrap the models inside an App Engine application using the splits previous _version = 0.2, new _version = 0.8 configuration. Option C, wrap the models inside a Cloud Run container using the revision 1 = 20, revision 2 = 80 revision configuration. Option D, implement random splitting in Dataflow using beam partition, with a partition function calling a Vertex AI endpoint.
To arrive at the correct answer, we focus on the keywords: Dataflow, real-time predictions, split the traffic between the versions in an 80-20 ratio, keep the pipeline as simple as possible, with minimal management required.
The correct answer is option A. Deploy the models to a Vertex AI endpoint using the traffic split equals 0 equals 80, previous underscore model underscore ID equals 20 configuration.
Why is this correct? A. Vertex AI endpoints provide native, fully managed support for traffic splitting between deployed model versions. This directly fulfills the 80:20 split requirement while keeping the pipeline simple with minimal management overhead. Why are the others incorrect? B. While App Engine supports traffic splitting, it is designed for web apps. Wrapping ML models inside App Engine introduces unnecessary operational overhead compared to a dedicated ML platform like Vertex AI. C. Cloud Run supports traffic splitting, but containerizing ML models and managing revisions requires more operational effort than using Vertex AI endpoints, which are purpose-built for serving ML models natively. D. Implementing random splitting within Dataflow using beam partition adds custom logic and complexity to the data pipeline, which contradicts the explicit requirement to keep the pipeline as simple as possible.
You work for an online publisher that delivers news articles to over 50 million readers. You have built an AI model that recommends content for the company's weekly newsletter. A recommendation is considered successful if the article is opened within 2 days of the newsletter's published date and the user remains on the page for at least 1 minute. All the information needed to compute the success metric is available in BigQuery and is updated hourly. The model is trained on 8 weeks of data. On average, its performance degrades below the acceptable baseline after 5 weeks, and training time is 12 hours. You want to ensure that the model's performance is above the acceptable baseline while minimizing cost. How should you monitor the model to determine when retraining is necessary? The options are: Option A. Use Vertex AI model monitoring to detect skew of the input features with a sample rate of 100% and a monitoring frequency of 2 days. Option B. Schedule a cron job in cloud tasks to retrain the model every week before the newsletter is created. Option C. Schedule a weekly query in BigQuery to compute the success metric. Option D. Schedule a daily Dataflow job in Cloud Composer to compute the success metric.
To arrive at the correct answer, we focus on the keywords: weekly newsletter, success metric is available in BigQuery, minimizing cost, monitor the model to determine when retraining is necessary.
The correct answer is option C. Schedule a weekly query in BigQuery to compute the success metric.
Why is this correct? C is correct because the success metric can be calculated directly in BigQuery where the data resides. Given the weekly newsletter cadence, a weekly query is the most cost-effective and direct way to monitor the true business metric. Why are the others incorrect? A is incorrect because using model monitoring for feature skew evaluates a proxy metric. This is less accurate and unnecessary when the actual business success metric can be directly computed. B is incorrect because it proposes retraining the model blindly every week rather than monitoring its performance. This violates the explicit requirement to minimize costs. D is incorrect because using a Dataflow job introduces unnecessary architectural complexity and cost compared to native BigQuery scheduling. A daily frequency is also excessive for a weekly newsletter.
You need to build classification workflows over several structured datasets currently stored in BigQuery. Because you will be performing the classification several times, you want to complete the following steps without writing code: exploratory data analysis, feature selection, model building, training, and hyperparameter tuning and serving. What should you do? The options are: Option A. Train a TensorFlow model on Vertex AI. Option B. Train a classification Vertex AutoML model. Option C. Run a logistic regression job on BigQuery ML. Option D. Use scikit-learn in Vertex AI Workbench user-managed notebooks with Pandas library.
To arrive at the correct answer, we focus on the keywords: classification workflows, structured datasets, BigQuery, without writing code.
The correct answer is option B. Train a classification Vertex AutoML model.
Why is this correct? B. Vertex AutoML classification automates the entire machine learning pipeline for structured datasets, including exploratory data analysis, feature selection, training, hyperparameter tuning, and serving, entirely without writing any code. Why are the others incorrect? A. Training a custom TensorFlow model on Vertex AI requires writing model and training code, which violates the without writing code requirement. C. BigQuery ML requires writing SQL queries to build, train, and evaluate models, which violates the without writing code requirement. D. Using scikit-learn in pandas in a Jupyter notebook requires writing custom Python code for data processing and modeling, violating the without writing code requirement.
You work for a bank and are building a random forest model for fraud detection. You have a dataset that includes transactions, of which 1% are identified as fraudulent. Which data transformation strategy would likely improve the performance of your classifier? The options are: Option A, modify the target variable using the box-Cox transformation. Option B, z-normalize all the numeric features. Option C, oversample the fraudulent transaction 10 times. Option D, log transform all numeric features.
To arrive at the correct answer, we focus on the keywords: random forest model, 1% are identified as fraudulent.
The correct answer is option C, oversample the fraudulent transaction 10 times.
Why is this correct? C. Since only 1% of transactions are fraudulent, the dataset is highly imbalanced. Oversampling the minority class provides the random forest model with more examples to learn from, improving classification performance. Why are the others incorrect? A. The box-Cox transformation is used to normalize continuous data, but the target variable for fraud detection is categorical, fraud or not fraud, so this transformation cannot be applied. B. Random forest models are scale invariant because they use rule-based partitioning rather than distance metrics. Therefore, z-normalizing numeric features is unnecessary and will not improve performance. D. Random forests are tree-based models that split data using thresholds, making them insensitive to monotonic transformations like log transforms. Transforming numeric features won't improve performance.
You recently deployed a pipeline in Vertex AI Pipelines that trains and pushes a model to a Vertex AI endpoint to serve real-time traffic. You need to continue experimenting and iterating on your pipeline to improve model performance. You plan to use Cloud Build for CI/CD. You want to quickly and easily deploy new pipelines into production, and you want to minimize the chance that the new pipeline implementations will break in production. What should you do? The options are: Option A, set up a CI/CD pipeline that builds and tests your source code. If the tests are successful, use the Google Cloud Console to upload the built container to Artifact Registry and upload the compiled pipeline to Vertex AI Pipelines. Option B, set up a CI/CD pipeline that builds your source code and then deploys built artifacts into a pre-production environment. Run unit tests in the pre-production environment. If the tests are successful, deploy the pipeline to production. Option C, set up a CI/CD pipeline that builds and tests your source code and then deploys built artifacts into a pre-production environment. After a successful pipeline run in the pre-production environment, deploy the pipeline to production. Option D, set up a CI/CD pipeline that builds and tests your source code and then deploys built artifacts into a pre-production environment. After a successful pipeline run in the pre-production environment, rebuild the source code and deploy the artifacts to production.
To arrive at the correct answer, we focus on the keywords: use Cloud Build for CI/CD, quickly and easily deploy new pipelines into production, minimize the chance that the new pipeline implementations will break in production.
The correct answer is option C, set up a CI/CD pipeline that builds and tests your source code and then deploys built artifacts into a pre-production environment. After a successful pipeline run in the pre-production environment, deploy the pipeline to production.
Why is this correct?
C. Building and testing source code early, then validating the pipeline in a pre-production environment before promoting the same artifacts ensures safety and minimizes the risk of production breakage.
Why are the others incorrect?
A. Manually using the Google Cloud Console to upload artifacts bypasses automated CI/CD principles and lacks a pre-production environment for full pipeline validation. B. Unit tests should be executed on source code during the build stage before deployment, not run in the pre-production environment after artifacts are already deployed. D. Rebuilding source code after pre-production testing violates best practices. It risks deploying different, untested artifacts to production instead of the exact ones validated.
You work for a bank. You have created a custom model to predict whether a loan application should be flagged for human review. The input features are stored in a BigQuery table. The model is performing well, and you plan to deploy it to production. Due to compliance requirements, the model must provide explanations for each prediction. You want to add this functionality to your model code with minimal effort and provide explanations that are as accurate as possible. What should you do? The options are: Option A. Create an AutoML tabular model by using the BigQuery data with integrated Vertex Explainable AI. Option B. Create a BigQuery ML deep neural network model and use the ml.explain_predict method with the number_integral_steps parameter. Option C. Upload the custom model to Vertex AI model registry and configure feature-based attribution by using sampled Shapley with input baselines. Option D. Update the custom serving container to include sampled Shapley-based explanations in the prediction outputs.
To arrive at the correct answer, we focus on the keywords: custom model, deploy it to production, model must provide explanations, minimal effort, as accurate as possible.
The correct answer is option C. Upload the custom model to Vertex AI model registry and configure feature-based attribution by using sampled Shapley with input baselines.
Why is this correct? C. Vertex Explainable AI integrates seamlessly with custom models in Vertex AI model registry. For tabular data, sampled Shapley with input baselines is the recommended attribution method when highly accurate explanations are required.
Why are the others incorrect? A. The scenario states you already have a well-performing custom model. Training a new AutoML model discards your existing work, violating the requirement to add functionality with minimal effort.
B. You already have a performing custom model.
Creating and training a new BigQuery ML deep neural network would require significant unnecessary effort rather than using the existing model. D. Manually updating a custom serving container to calculate Shapley values involves complex, custom coding, which contradicts the requirement to implement explanations with minimal effort.
You created an ML pipeline with multiple input parameters. You want to investigate the trade-offs between different parameter combinations. The parameter options are input dataset max tree depth of the boosted tree regressor optimizer learning rate. You need to compare the pipeline performance of the different parameter combinations measured in F1 score, time to train, and model complexity. You want your approach to be reproducible and track all pipeline runs on the same platform. What should you do? The options are: Option A. 1. Use BigQuery ML to create a boosted tree regressor, and use the hyperparameter tuning capability. 2. Configure the hyperparameter syntax to select different input datasets, max tree depths, and optimizer learning rates. Choose the grid search option. Option B. 1. Create a Vertex AI pipeline with a custom model training job as part of the pipeline. Configure the pipeline's parameters to include those you are investigating. 2. In the custom training step, use the Bayesian optimization method with F1 score as the target to maximize. Option C. 1. Create a Vertex AI workbench notebook for each of the different input datasets. 2. In each notebook, run different local training jobs with different combinations of the max tree depth and optimizer learning rate parameters. 3. After each notebook finishes, append the results to a BigQuery table. And the remaining options are Option D, 1. Create an experiment in Vertex AI Experiments. Point 2. Create a Vertex AI pipeline with a custom model training job as part of the pipeline. Configure the pipeline's parameters to include those you are investigating. Point 3. Submit multiple runs to the same experiment, using different values for the parameters.
To arrive at the correct answer, we focus on the keywords, ML pipeline, investigate the trade-offs between different parameter combinations, input dataset, compare the pipeline performance, reproducible, track all pipeline runs on the same platform.
Review the options on screen. The correct answer is option D, 1. Create an experiment in Vertex AI Experiments. Point 2. Create a Vertex AI pipeline with a custom model training job as part of the pipeline. Configure the pipeline's parameters to include those you are investigating. Point 3. Submit multiple runs to the same experiment, using different values for the parameters.
Why is this correct? D. Vertex AI Experiments is explicitly designed to track, compare, and analyze different pipeline runs on the same platform. Submitting multiple pipeline runs allows you to systematically investigate multi-objective trade-offs across metrics like F1 score, training time, and complexity. Why are the others incorrect? A. BigQuery ML's hyperparameter tuning is intended for optimizing model parameters, like tree depth and learning rate, but does not natively support selecting entirely different input datasets as part of the hyperparameter search space. B. Bayesian optimization in a custom training job focuses on maximizing a single objective metric, F1 score, making it unsuitable for investigating the trade-offs between multiple objectives like training time and model complexity. Why are the others incorrect? C. Using individual notebooks for local training is highly manual and lacks the reproducibility, automation, and centralized tracking capabilities natively provided by Vertex AI Experiments and managed pipelines.